Okay, let's go ahead and talk about how we usually fix functions that aren't one-to-one. Remember, since this function is not one-to-one, it doesn't pass the horizontal line test, which means its inverse won't pass the vertical line test. Okay, to fix this problem, what we want to do is we want to take a function, especially for x squared, and we want to make a vertical cut so I get two pieces and each of them are one-to-one. A great place to cut a parabola would be at its vertex. So what I'm going to do is I'm going to make a domain restriction. So let's only actually consider this function. Let's consider f of x, but I only want to think about f of x on the domain all x such that x is greater than or equal to 0. So if I'm only thinking about x squared for x greater than or equal to 0, I only have half my picture. And now, with half this picture, this is now a one-to-one function. And now I can go ahead and try to find its inverse. So to do that, we'll write y is equal to x squared. For this exercise, I'm actually, to find its inverse, I'm not going to flip-flop the x and y's quite yet. I'll actually do that at the end. Let's go ahead and solve for x by taking the square root of both sides. So we'd have x would be equal to the square root of y. Now, normally you would pick a plus or minus here. But what do I choose, the plus or the minus? Well, notice my domain restriction is x is greater than or equal to 0. So x has to be a positive value, so I need to choose the positive version. Okay, from here I can now flip-flop the x's and y's, so I can say here that, that the square root of x is equal to y, or what we would have here, I'm going to write it right here, is we'd have that the inverse of this function would be the square root of x. Be the square root of x. And we could draw that. How about we draw that we'll draw that in pink. So now I would just have the square root function. So if I have x squared and I'm just restricting this domain to x being greater than 0, then its inverse would be the square root function. But let's say I make a different cut. Let's say I'm still thinking about f of x, which is equal to x squared. But let's make a domain restriction. We can also restrict it for x less than or equal to 0. For all x such that x is less than or equal to 0. So now I'm only thinking about this piece of the function. We can go ahead and find a formula for its inverse. Okay, so let's say y is equal to x squared. If we go ahead and square root both sides, we'd have the plus or minus square root of y would be equal to x. But in this case, do I choose the plus or minus? Well, x here is a negative number, so I'm going to choose the negative version. Okay, from here I'll flip-flop the x's and y's, so I'll get the negative square root of x is equal to y, or we'll have that the inverse function for this domain restriction is equal to the negative square root of x. So the inverse for non-one-to-one functions depends on how you want to chop up the domain. Okay, let's give this problem here a shot. What I want you to do is I want you to sketch this function. I then want you to make a domain restriction so you have two pieces, each piece being a one-to-one function, and then I want you to find the inverse for each one of those. Give it a shot. Okay, let's do it. Let's first graph this function. So this is a parabola. It's shifted to the left 2 units, so -2 and up 1 unit. So this is where its vertex will be. And let's see, what's its y-intercept? If we plug in 0, we'll get 2 squared, we'll get 4 plus 1, we'll get 5. So here's 5. So the graph is going to look like this. Let's go ahead and make a cut on this parabola down the vertex. So now the right-hand piece will be a one-to-one function and the left-hand piece will be a one-to-one function. Okay. So for our first domain restriction, let's do the restriction. So the domain of f, let's restrict it to be all x such that x is greater than or equal to -2. And let's see what its inverse would look like. So I guess we're going to draw it. Here's -2 and here's 1. Here's 5. We're only thinking about the right-hand piece of it. Okay, now if I were to find its inverse, let's see here, I would have that y would be equal to x plus 2 squared plus 1. You could flip-flop the x and y's now. I'm actually going to choose to do it at the end. So I'm going to solve for x. So we'll get y minus 1 is equal to x plus 2 squared. Okay, then you would square root both sides, so we get the square root of y minus 1 would be equal to x plus 2. You remember we have to introduce the plus or minus. Now we have to decide whether we're choosing the plus or minus. Well, notice, since x is greater than or equal to 2, x plus 2 will have to be positive. So x plus 2 has to be positive. I need to choose the positive version. We could finish solving for x by subtracting 2 from both sides, so we get that x will be equal to the square root of y minus 1 minus 2. So now we could flip-flop the x's and y's, or I hope you can see that the inverse function is going to be the square root of x minus 1 minus 2. Let's go ahead and sketch this. So what is this? This is this is the square root function. It's shifted to the right 1 unit. It's shifted to the right 1 unit and down 2 units. Negative 2. So we're right here. Okay. And notice what happens if we plugged in 5. If we plugged in 5, 5 minus 1 is 4. Square root of 4 is 2. 2 minus 2 is 0. So when we plugged in 5, the output should be 0. So here, we have the graph of its inverse. Well, it's not a perfect drawing, but notice that these are reflections of one another over the line y equals x. So if we take this function, we make this domain restriction, this will be its inverse. Similarly, if we wanted to make a different domain restriction, let's say we'll do it in red. Let's say I want to make the domain restriction the domain of f. Let's say it's all x such that x is less than or equal to negative 2. Okay? In this case here, let's see what would be true if I want to find a formula for its inverse. Well, I guess let's draw it. I only want the piece that's less than negative 2. So I don't need the green right now. So let's go over negative 2. Okay, let's go up 1. So we'd only care about the left-hand piece here. Okay, so if I were to find the formula for the inverse, we'd have y would be equal to x plus 2 squared plus 1. Okay, I'm just going to go ahead and solve for x, so we'll get y minus 1 is equal to x plus 2 quantity squared. Now we'll square root both sides. We'll have the plus or minus y minus 1 will be equal to x plus 2. But do we choose the positive or negative version? Well, since x is less than or equal to negative 2, x plus 2 will be negative, so I need to choose the negative version. So now we could subtract 2 from both sides, so we get that x is going to be equal to the negative square root of y minus 1 minus 2, or its inverse. Its inverse, now I flip-flop the x's and y's, and switching back to inverse function notation, this will be the negative square root of x minus 1 minus 2. So now this is the square root function, except the only difference, it's pretty much the same as this one, but the only difference is it's reflected over the x-axis. So we're still going to be shifted down 2 units, so here's negative 2, and we're going to be shifting to the right 1 unit. Will be right here, and it's not going to do this because it's reflected over the x-axis. It's going to look like this. Now notice that these are reflections over the line y equals x. So if we have this function and we make this domain restriction, then this here will be its inverse. And that's how we fix problematic functions. We break the function that's not one-to-one into a bunch of one-to-one pieces, and we find inverses for each of those pieces. Hope you found this video helpful. We'll see you in the next one. Take care.